Okay, we are doing 7.4, which is properties of logs. Now, before I talk about these properties, okay, and the properties we're going to use, I want to tell you that log world is very topsy-turvy. It's weird. It's kind of like a Dr. Seuss book, okay? So when I say things, it's part of their property. It's something you're going to end up, once you get it, you're going to like it, okay? So for example, if I have the log of xy, so I have two things multiplied together. In the log world, that means we really add them. So this is actually the log of x plus the log of y. So anytime you see two of them multiplied together, you're really adding. In the log world, when we are dividing, we're really subtracting. In the log world, if I have an exponent, so x to the y, that exponent is really the leading coefficient. So this is y times log of x. So when you have an exponent right here, we get to move it to the front. And the last property I want to talk about is any time you have the log of a base and behind it's the same, it equals 1. Those are our four properties. Almost. So we're going to use those properties. Here is example number 1 in the first section today, which is 10 through 16. They ask you to write as a single, log. So what we're going to do is we're going to take something, we're going to condense it down. We're going to start off really easy. So let's say I have the log of 7 plus the log of 2. Incorrect. Good try, though. So go back to that first property. What did that first property say? Yes, when we add in log world, we're really multiplying. So this is log 14, exactly. No. Try another one. Let's say I have log 21 minus log 3. Log 7, very good. Log 7. I knew that. No, not yet. Okay. Do one more with numbers so it makes total sense. Let's say I have log base 2 of 2 to the 5th. That one came out of your homework, right? So this has two properties in it. That's what I want to talk about. The first property says if I have an exponent, it gets to go to the front. 5 log base 2 of 2. The very final property I gave you said that when I have log base 2 of 2, what does that equal? It equals 1. That was our final property. So if this equals 1, 5 times 1 means this is 5. And of course, the other way we did it yesterday, you told me it was 5. We just did it a different way. Okay, so we've got these properties. Here's example number 2. same problems for a second, but we're going to add in some variables. So let's say I have log base 3 of x plus log base 3 of y minus log base 3 of z. We're going to start with the first two. In the log world, when we add, we really multiply. Exactly. In the log world, when we add, we really multiply. So this becomes log base 3 of xy minus log base 3 of z. Now, in the log world, when we subtract, we really do what? We divide. So this becomes log base 3 of xy divided by z. Okay, let's do one more, and then we'll go to the next section. All right, let's do, looking for a tougher one. I don't see one, though. How about this? Let's say I have log base 4 of w minus 2 log base 4 of k. All right, so if you have any coefficients in front, that's the first thing we got to move. So this coefficient right here is actually the exponent on k. So we have log base 4 of w minus log base 4 of k squared. Now in the log world, when we subtract, we really divide, absolutely. So we write log base 4 of w divided by k squared. Questions so far? All right. Example number 3. All right, this is taking you to 18 through 28. All right, 18 through 28. Expand the log. All right, so we're going to do opposite what we just did. So let's say I have log of x squared y to the third. So x squared and y to the third are multiplying. So in the log world, that means we're going to add. Absolutely. So I have log x squared plus log y to the third. We still have one more property we get to do. If you have an exponent, where does it go? To the front. So I'm going to take this 2 right here, and it goes to the front. This 3 right here goes to the front. So my final answer would be 2 log x plus 3 log y. Let's try another one. All right, how about if I have log base 3 of 2 times x minus 1 squared? All right, so tell me behind that log, I have a 2 and I have this parenthesis that's squared. What are those two things doing? They're multiplying, right? Technically, this 2 multiplies this. So in the log world, if we're multiplying, we're really adding. So I have log base 3 of 2 plus log base 3 of x minus 1 squared. So now I've got one thing left to do. What is it? Yes, this 2 right here has to go in front of the log. So I have log base 3 of 2 plus 2 log base 3 of x minus 1. Okay, so any questions here? How are we doing? We're doing okay? No questions? All right, let's go to example number 4. In example number 4, let's stay in the same section real quick. Let's continue expanding. But let's say I have log square root x over y to the third. No, not quite. You're going to subtract them, I agree. First of all, let's start with that x on top. If it's in a square root, how else can I write that with a fractional exponent? To the 1/2. So this is really log x to the 1/2 over y to the third. And in the log world, when we divide, we really subtract. So I have log x to the 1/2 minus log y to the third. Now I have to take those wonderful exponents, and we're going to move them to the front. All right. That means I have 1/2 log x minus 3 log y. All right. The next section we're going to talk about is called the change of base theorem. Change of base theorem, you're simply rewriting it in a different form. All right, so we have, actually, let's do this. Change, oh my goodness, of base. I know. Change of base. If I have the log base b of y, I can actually rewrite this as log base 10, so I don't have to write anything, of y divided by log base 10 of b. This is called the change of base theorem. The reason we use it is because back in the day, we didn't have cool calculators that we could type in the actual problem and get out the answer. So it's up to you whether you use the change of base formula or you find in math log base. But here is example number 5. So example number 5, this is 30 through 36. Using change of base, evaluate. And let's say I have log base 3 of 7. I can change this into log 7 divided by log 3, and then I can use the front part of my calculator without going into any buttons. Or I can just type into log base 3 of 7. So you can go to either place. We're going to go to our calculator. If you choose to use the base, change of base formula, you notice log is on the left right next to 7. So you hit log 7, close your parenthesis, divided by log 3, close your parenthesis. You get out a beautiful decimal. You would get the same exact decimal if you went to log base in math. So we get 1.771. It doesn't matter which place you go. You just put it in your calculator. Okay? All right. Last 2 examples. 2. We still got one more section to go over. Here is example 6. This is from 40 to 44. Oh, actually before that, my bad. Please omit, which means leave out, 38. Do not do. Do not do 38. Okay. Example number 6 is 40 through 44. Using properties of logs, evaluate. So let's say I have log base 2 of 4 minus log base 2 of 16. All right. So in the log world, when we subtract, we really do what? Divide. So I can start by going log base 2 of 4 divided by 16, which is the same as log base 2 of 1/4, right? Guys agree there? Okay. Now, 4 I can change into 2 squared. So I have log base 2 of 1/2 squared. Everybody still agree? Now, how do I move something with an exponent to the top? What can I do to my exponent so I can move it to the top of my fraction? Make it negative. Make it a negative exponent. So this is actually the same as log base 2 of 2 to the negative 2. So now my exponent goes to the front. So I have negative 2 log base 2 of 2. And what does log base 2 of 2 equal? It equals 1. That was our fourth property. So I get to cross that out, and my answer is negative 2. Okay. You won't forget it. You'd be surprised. Let's do one more. This is the last one. Example 7, right? Yeah. Example 7. This last one, same section. Let's do... Oh, let's do this. Log base 3 of, log base 4, my bad. Log base 4 of 48 minus 1/2 log base 4 of 9. So the first thing we're going to do is we're going to take that coefficient and put it where? It is in front of log. What do I want to do with it? Make it an exponent. Thank you, Lex. We're going to make it an exponent. We're going to take this and make it an exponent. So I have log base 4 of 48 minus log base 4 of 9 to the 1/2. Well, what is 9 to the 1/2? No. It's a square root. It's 3, exactly. So this is log base 4 of 48 minus log base 4 of 3. Now, in the log world, when we're subtracting, we're really dividing. So we're going to have log base 4 of 48 divided by 3, which is 16. Okay? Now, how can I write 16? For what? 4 to what power is 16? Squared. So I have log base 4 of 4 squared. Technically, where's the 2 go? In front of log. So we get 2 log base 4 of 4, which this just equals 1. So it equals 2. Yes, you will. Yes, you will. It's just using the properties. Yes. Go ahead. Go quickly. So here's the thing, you guys. The first part is going to get you practicing these different properties. They're not bad. It's really actually super easy once you get the properties down, okay? Because it's all weird. It's going to be your habit to want to, if they're multiplying, to keep multiplying. It's going to be your habit to want to divide, okay? All right? So you've got to think outside the box, okay? You got this. You got this. So you still have 15 minutes